Hello everyone, welcome to our day 11 discussion. Okay, today we are going to discuss about the deployment in Kubernetes. Let's do a quick recap what we have discussed in our day 10 class. In our day 10 we discussed about the services. Okay, and in Kubernetes we have three types of services. The first one is called as ClusterIP, the second one is called as NodePort, and the third one we have LoadBalancer. The cluster IP, I would say, and the NodePort are provided by the Kubernetes. Okay, both of them. And this one is for the internal configuration only. Whatever the IP of this cluster IP you are going to get, it would not be public. Okay, and this one NodePort is not recommended in real-time scenarios because it exposes the port of each node. And finally, we discussed about the load balancer, which is provided by, I would say, from the cloud provider. This one is layer 4 load balancer. So let me do a quick recap what we have discussed till now. We discussed the smallest unit which we have in Kubernetes is our pod, I would say, replica set. Okay, replica set. And finally, the replica set was connected to service for an internal and, I'll say, service for an internal and external environment connection. Okay, we already have a very detailed discussion, like this is a pod, and inside this pod what we are going to have, we are going to have containers. Okay, we are going to have containers, and containers uses what, a image. Then what we have, a replica set. The main task of the replica set to make sure some specific number of pods are always running. And then finally, the replica set is going to connect it to my service. And the service can be your load balancer, cluster IP, and NodePort. And it will provide a single entry point to our application. So these are the things which we have discussed till now. I would say currently my application is running on version 1. Okay, and my developers have created a new version called version 2. Okay, so in this case what we are going to do, till now whatever we have discussed, I'm going to update my version here, the version number from version 1 to version 2. Okay, this is the one of the option. The first option, I would say, we have to update the YAML file with new version. Okay, do you think this practice is good? The answer is no. Okay, so this approach is not recommended in real-time scenario where you're going to update, I would say, directly the pod image. Okay, why this approach is not recommended? In this approach, we do not have the features of rolling update. So what is the exact meaning of rolling update? We'll discuss about it, but it will make sure we have zero downtime. Okay, the second option which we do not have, rollback support. Rollback support means I have released from version 1 to version 2. I feel like the version 2 is not up to the mark. Okay, some users are not happy and they are facing some issue in terms of, I would say, loading the application. So what I'm going to do, I want to undo the old version, okay, from version 2 to version 1. So this feature is also not supported by our replica set. And the third option which we have is version control. So what is the exact meaning of version control? It will maintains history of changes. Okay, so I would say I'm moving from version 1 to version 2. Then from version 2 to version 3. So if I want to move back to version 1, so how we are going to do it? To move from version 3 to version 1, we need to use version control. I would say this feature is not supported by our replica set. To support the rolling update, the rollback support, the version control is done through a new object which is called as deployment. Okay, which is called as deployment. So our new hierarchy, it would be like this. The smallest one where we are going to create all our pods. Then it is going to connect to my replica set, which will make sure some specific number of pods are always running. Then what we have deployment. So what is the purpose of deployment? To make sure we have rolling updates, rollback supports, and version control. But there are some other features that are also available in deployment, which we are going to discuss throughout this video. And finally, what we have? We have services. And what is the purpose of services? To expose our application in its internal or external environment. Basically, we have, I would say, this is my deployment. Okay, so we have two types of deployment. Okay, the first one is called as rolling update, and the second option which we have is called as recreate. Okay, so what is the difference between the rolling update and the recreate? In one line, if you ask me, for the rolling update, we do not need any downtime. While in the case of recreate, I would say downtime is required. There's one typo. So downtime is required. So firstly, we are going to focus on rolling update. Then we are going to discuss about the recreate. So let me do a quick demo to understand the rolling update. Then I will discuss about the recreate. So to implement the, I would say, rolling update, I'm going to create an object name called as deployment. Okay, and as I have mentioned, as per the hierarchy, if I'm creating deployment, so automatically a replica set will be created. What we are going to have? We are going to have the pods. Okay, and then this deployment, it would be connected to service. So this is the part which I'm going to do. Then this pod, I would say, is using version 1. Then I'll move the pod image from version 1 to version 2. Okay, and then we will see at the service end, are we able to see version 1 or version 2? Okay, let me do a quick demo to understand this one in detail. So for this demo, I have already created a cluster name called as demo-aks. Let me select the subscription, click on connect, then set the cluster subscription and paste it here. The second one is download cluster credentials. So I'm connected with my demo-aks cluster. Let me run a command called kubectl get nodes. Okay, so as we have discussed, to implement this demo, the first thing which I'm going to create is my deployment. Okay, and then this deployment, it will be responsible to create the replica set and then my pods. And finally, I'm going to use an image version called v1, and this deployment, it will be connected to my load balancer service. Okay, and once this part is done, what I'm going to do, I'm going to change from version 1 to version 2. Okay, let me firstly implement this first step, then we will discuss about this second step. In the Visual Studio, I'm going to create a file name called as rollingupdate.yml. If you see in this YAML configuration, the kind is deployment, the name is rollingupdate-demo, and the replicas number is 5, and this is a selector, and this is the template which we are using, and the specification details is container C1, and this is the image version B. Okay, so let me run this YAML configuration. Copy path. Okay. I'll run a command called kubectl create -f rolling update. Let me go inside the folder day 11 and we'll run a command called kubectl create -f rolling update.ym. Okay, so it has been created. As I have mentioned multiple times, once we are going to create our deployment, it is going to create what? A replica set, and the replica set is going to create the specific number of pods. Okay, and then we are going to connect it with service. So let's firstly prove me this point. Okay, I'll run a command called kubectl get deployment. So you see here what we have, rolling update hyphen demo. I will run a command called kubectl get replica set. So replica set is also created. I will run a command called kubectl get pods, and our pods are also created. Let me describe my kubectl describe deployment, and the name of my deployment is rolling update hyphen demo. Okay, so if you see here, our deployment part has been completed, and while describing the deployment, we are able to see a number of components like rolling update strategy, I would say old replica set, new replica set, and the other things are same. I would say the namespace, the labels, the annotation, selector, replicas, and the strategy type 2, okay, which is rolling update. So what I'm going to do, I'm going to create a new service. If you see in this kubectl describe deployment option, the first one is name, namespace, creation time, labels, annotation, selector, replicas. Then we have our strategy type as rolling update. Then the rolling update strategy, which we are going to discuss, and the pod template, the condition, the old replica set, the new replica set, and these are the events. Okay, I would say we are good to ignore rolling update strategy, old replica set, new replica set. Let me firstly create a service to connect to my deployment. The command is kubectl expose deployment, the rolling update hyphen demo. This is my target port, and this is my port, and the type is load balancer. Let me press on. Let me run this command. So finally, our rolling update hyphen demo deployment has been exposed using service. I will run a command called kubectl get svc, and I'm waiting for my external IP. So I'll run a command called hyphen watch. There's one typo. Okay, so the external IP is this one. Let me copy this one and paste in my browser. It will take some time to reflect. So finally, we have welcome to rolling update demo. This is my pod name, and what is this one? This is my version 1. I will run again. See, it is pointing to different pods, and the colors are also changing. So till now, what we have done, I would say the deployment is equal to my replica set. The same thing we have done in our replica set configuration also. But as I have mentioned, what we are going to do, we are going to change the version. So what would be the version? It would be from version 1 to version, I would say version 1 to version 2. Okay. To update this version, what I'm going to run, I'm going to let me clear my screen. Let me firstly clear my screen. Okay. So I'm going to run a command called kubectl set image deployment, and my deployment name is rolling update hyphen demo, and the new container image, it would be this one. If you see at the end what we have version 2. Initially what we had version 1. Okay, so let me run this command. The command is kubectl set image deployment, and this is my deployment name, and the container image is version 2. Initially what we had, the version 1. Let me press on enter. Okay, so eventually what it is going to be done, which is pointing to in our deployment, which is pointing to my replica set, and then my pod, whatever the image initially we had version 1, it is going to change to whom? To version 2, and this deployment is connected to my service. Okay, so at this IP, when we are going to refresh, either we'll get the input from version 1 or we'll get the input from version 2. But at any point of time, you will not get any blank screen. Okay, so let me open my Visual Studio Code. So let me open the Chrome and refresh it. See, the new version which we are able to see is version 2. Have you seen any kind of downtime? The answer is no. So I think it is a good time to discuss about the describe command in deployment. It is kubectl describe deployment, and the deployment name is this one. Okay, let me clear my screen. As I have mentioned, what we need to discuss? We need to discuss about the rolling update strategy, which is mentioned 25% maximum unavailable, 25% search. And the second thing which we need to discuss is about the old replica set and the new replica set. And these are the events which we are able to see. Before discussing this point, let me run one more command called as kubectl get replica set. As you can see here, what we have the two replica set. And this one is my old replica set. Okay. And this one is my new replica set. In the new replica set, we have 5 pods in a running state. Let me firstly discuss about the rolling update strategy in whiteboard. Then we are going to discuss the other points. So let me discuss what is happening while doing the rolling update. So the first thing which we have discussed is our deployment. Then my deployment is connected to my replica set, and then it would be the responsibility of my replica set to create n number of pods. Okay, and then my deployment, it would be connected to my service, and then this service is going to provide what? A public IP to access our application. So I would say this is my replica set. Okay, and in this replica set, we created 4 pods: pod 1, pod 2, pod 3, and pod 4. This one is my pod 1, pod 2, pod 3, And finally, what we have, our port 4. So all the 4 ports are created, and I will mention this one as old replica set. The next thing which I'm going to do, the image which we are using here is version 1. What I have done, I have updated this one with a new version, and the new version is version 2. And for the new version, what it has done, it has created a new replica set, new replica set with new ports, with new ports. Okay, but from the user end, I would say what we have done, we have shared this public IP. When we were accessing from the browser, have we received any kind of downtime? Means when we try to access this URL and we were not able to access, the answer is no. How the rolling update was able to achieve this one? So the new version, I would say this one is V2. So what it is going to do, means we are going to update the version from version 1 to version 2. It is going to create a new replica set. Okay, what it is going to do, it is going to create a new replica set. And in the new replica set, what would be the purpose of this new replica set? To create a new pod. So I will say this one is my new pod 1. Okay, once this new pod is created, it is going to delete the old pod. Then again it is going to create what? A new pod name called as new pod 2, and it is going to delete the old pod, and then it is going to create a new pod name called as np3, and the same process it is going to do. It is going to delete the pod 3, and finally it will create a new pod 4, and it is going to delete the old pod. So the current workload, if you see, initially what we have 4 pods present inside my old replica set. All the 4 pods have been deleted, and all the 4 pods are present here, and all the traffic will be routed from this new pods, and this version 1 pods number will be equal to 0, and version 2 pods will be equal to 4. And if you see here, finally all the new pods have been created in my new replica set. Okay, how we are able to achieve this behavior? The pods were getting deleted in this replica set, and the new pods were getting created in this replica set. So if you see here, we have one option called rolling update strategy. So what is the exact meaning of this one? It will make sure at any point of time we are going to have 25% surge. So in the case of 4 pods, we are good to have one extra pod, okay, and 25% unavailable. It means we are going to have one less pod, which it would be 3 pods. Okay, but it will make sure the maximum number of pods it would be 5, and the minimum number of pods it would be 3. Okay, and the second thing which we need to discuss is the old replica set. In the old replica set, whatever the pod were present, it has been moved to new replica set. Okay, and this old replica set is empty. And whatever the events are happening, I would say, moving the pods from old replica set to the new replica set. So these are the events are present here. And if you see at the end, you will see the old replica set version, which is C6CCC. It is to 0 from 1. Okay, so this is all about the rolling update strategy. The main benefit of rolling update strategy is it will make sure there would be 0 down time. Okay, so at the deployment level, it is going to create the old replica set and new replica set. And once all the pods have been moved to the new replica set, so the traffic will come to the new replica set. While in the transition state, means moving the pod from the old replica set to the new replica set, it will make sure the traffic is well regulated between the old pods and the new pods. In more technical way, in the old replica set or the new replica set. Okay. So this is the first benefit which we have discussed, like using the deployment, we are going to have the zero downtime. The second benefit which we have discussed is it is make sure we are good to have the rollout history. I'll run this command called kubectl rollout history deployment and my deployment. So what I'm going to do, I'm going to move the version from version 2 to version 3. Again, I'm going to run a command called kubectl set image deployment. Let me run this command. There's one typo. As you can see, we are able to access our application and it is showing the newer version. Okay. Let's say if I want to undo the version. So what is the meaning of undo the version? Means I'm not happy with version 2 and I want to move from version 3 to version 2. What would be the command to do it? It would be kubectl rollout undo deployment rolling update hyphen demo. Okay, so deployment.apps rolling update hyphen demo rolled back. I will again refresh this one. You'll see it is showing version 2. Okay, so this is the benefit. If we are using deployment object, we are good to update version 1 to version 2 without any downtime. Okay, the second benefit which we have is it would be responsibility of deployment to save all the version and we are good to undo from one version to the another version. And let me run a command called kubectl describe deployment and my deployment name was rolling update hyphen demo. We have this older version and if you see here what we have, this one is my new replica set and this one is my old replica set collection. It would be the responsibility of my deployment to make sure it has all the version of my replica set. So there will be one deployment and it will have version 1 replica set, version 2 replica set and version 3 replica set. So if you are going to say I want to undo from version 3 to version 2, it will undo this one, means it will move all the pods from the newer version to the older version. Okay, if I'm going to run this command again, let's see what is going to happen. It has rolling update hyphen demo rollback. Let me refresh it again. Again we have version 3. So this is a benefit of using deployment. We are going to have zero downtime while moving from one version to the another one. And the second benefit which we have is if we are moving from the older version to the newer version and you're not happy from the newer version, we are good to undo it, which means we are good to move from the newer version to the older version. And it would be the responsibility of the deployment. Okay, it would be the responsibility of the deployment to save all the older versions, means older replica set and the new replica set. At any point of time, if you are pointing to undo the old version, what it is going to do? It is going to move from the new replica set to the old replica set. And here I have mentioned we have two replica set. The first version 1, the version 2, and here what we have with the version 3. And when we are saying like, okay, I want to undo from version 3 to version 2, it is activating this replicas and all the traffic is moving to the version 2. Okay, and while doing this one, it will make sure we have zero downtime. Okay, so let me delete this YAML configuration. Okay, let me go to this part. So let me delete this YAML configuration. Let me quickly copy the path, cd Okay, so with this we have completed our rolling update discussion. Let me delete the services also. kubectl get svc, kubectl delete svc, and the name is rolling update hyphen demo. Let me open the whiteboard. Okay, the second type of deployment which we have discussed is recreate. Well, in the case of recreate, as I have mentioned, well, in the case of recreate, as I have mentioned, zero downtime which we were getting in rolling update will not be able to achieve. In this case, if we are going to use a recreate, we will face some downtime. So what would be the logic behind this one? Again, it would be the same thing. We are going to create one deployment, and this deployment will create the replica set, and the replica set will create the pods, will firstly connect to a service. Okay, and then what we will do, the C1 is using version 1, will create a new replica set, it will create a new pod, and it will have the version 2. But from the user end, whatever the IP, and from the user end, whatever the IP we are going to use, till now, when our application was moving from version 1 to version 2, we did not face any kind of downtime. Means at the user end, either we were getting version 1 or version 2. But in the case of recreate, there would be some downtime. So let me do a quick demo to understand this one in detail. So the YAML file it is recreate-demo.yml. Okay. So if you see in this YAML configuration, the kind is deployment, the name is recreate-demo, and here I have mentioned the 4 replicas, and this one is my selectors, this is a template, and this is the image. And if you see here, the strategy which I have mentioned is recreate. While initially what we have mentioned, we mentioned about the rolling update. So this one, it is going to create the deployments, and then my replica set, and finally my pod with version 1. Okay, and then we are going to connect with our service, and this service will get the IP. I would say whatever the first step we are going to implement, it would be same for recreate or rolling update. The main story, it would be started to moving from old replica set to the new replica set at the user level. Okay, so let me run this YAML configuration quickly. I have created this one. Then I'm going to expose this deployment using load balancer. Okay, there's one typo. The deployment type which I have mentioned is my app, but I have created a deployment name called as recreate hyphen demo. Okay. Let me run a command called kubectl get svc. I will mention hyphen w. It generally takes around 30 to 40 seconds to get the IP. Here we have our IP. As you can see here, we are able to see the version 1, and this is the same point which we have discussed till now. What would be the purpose? We have version 1, and initially from the user end, we are able to see the version 1. Here comes a twist. What I'm going to do, I'm going to update the image version 1 to version 2. Okay, so then my image has been updated. So this is my public IP. Let me copy this one. See here, which version we are able to see? We are able to see version 2. Let me change the version, I would say, from version 2 to version 1. Let me press enter. And let me refresh it. See, it is showing version 2. Currently, the application is not reachable. It was showing version 2. Right now, it is showing version 1. So what is the exact meaning of this one? Whenever we are using recreate it will give us the downtime. Which means right now we have only 4 pods. That's why there's very minimum downtime, I would say. But in real time scenario, we cannot use recreate strategy. We always prefer to use rolling update. It will make sure either you are going to get the pods from the old replica set or from the new replica set. Okay. Well, in the case of recreate, firstly, it is going to delete all the pods from my old replica set. Outside I have 4 pods, and then firstly it is going to delete the first pod, second, third, and fourth, and then it is going to create a new pod in my new replica set. So while it is going to delete all the pods and it is going to create a new pods in the new replica set, if you see, there would be some downtime. And from the user end, when we were trying to accessing, it was showing the version 2, but when it was moving from version 2 to version 1, for a while what we got, the site is not reachable. It is good to say whenever we are using a recreate, at that time we'll face some downtime. I can explain this command called kubectl get deployments. Okay, kubectl describe deployment, and the name is recreate-demo. And here if you see what we have, our old replica set and the new replica set, and the strategy type is recreate, and currently we do not have any options of 25% search or 25% of unavailable. Why? Because we are using recreate strategy. You see here what it has done, we have our old replica set, this one, and the new replica set is this one. So if you check the latest log, this one, scale down replica set recreate, which is 581 from to 0 from 4, which means this is my replica set, old replica set. In this replica set, I would say we had 4 pods. Okay, so the first thing they have done, they have scaled down replica set recreate-demo to 0 from 4, which means they have deleted this pod, they have deleted this pod, they have deleted this pod, and they have deleted the last pod. Okay, then there is a kind of downtime. Then here they have created the 4 pods, first, second, third, and fourth from 0. Okay, so this is the difference between the rolling update and the recreate. In the rolling update, what we have discussed, it was making sure from the user end there is not any kind of downtime. They were getting the traffic from the old replica set or the new replica set. Okay, so the last type of deployment which we are going to discuss is blue and green deployment. Right? So what is the meaning of this blue and green deployment? So till now what we have discussed, we have our deployment. Okay, and then my deployment is connected to my replica set, and then replica set was connected to my pod, and the pod was using some specific image to run my application. And when we were moving from one version to the another version, so what it was doing, it was creating one more version of my, I would say, my new replica set with new pods and with new image. Okay, and from the user end, what we have done, we have our services which was connected. Okay. And even here we discussed about the 2 types of deployment. The first one was rolling update and the second one was recreate. Rolling update, as we have discussed, there would be no downtime, while in the case of recreate there would be some there will be downtime because firstly it is going to delete all the pods from the old replica set, then it is going to create a pod in our new replica set. So till now what we have implemented, we have implemented the rolling update and recreate. Both of them are working on the basis of replica set. I would say from the old replica set to new replica set. Okay, so when it is moving from the old replica set to new replica set, are we able to do any pre-checks in our new environment? The answer is no. Are we able to do any kind of verification on this new environment? No. Are we able to control like how much traffic will go to this new environment? The answer is no. All the 100% traffic is moving to this new replica set. To new replica set. To get this kind of feature where before deploying, I would say the new version 2 inside the production environment, we are good to check or verify some configuration or do some UAT. And the third type of deployment which we are going to discuss is blue-green deployment. Okay, so I'll say till now what we have done, we have our deployment, and then this deployment is connected to my service, and then at the deployment level what we had the old hyphen replica set and new hyphen replica set. So this is the part which we have discussed till now. But if you see, what is the exact issue here? From the user end, we discussed the two type of deployments. The first one it was rolling update and the second one was recreate. In both the cases, what we are doing from the user end, I would say IP, we are playing at replica set. So user will get this old replica set or the new replica set pods. But are we able to control the behavior? Which means before moving this new replica set, are we able to do any kind of testing or any kind of configuration check? The answer is no. So to overcome this kind of challenges, what we have the another kind of deployment which is called as blue-green deployment. So this one it would be my service, and this service it would be connected to my blue deployment, which means it will have its own replica set pods, and the second option which we have is green deployment. It will have its own replica set hyphen pods. Okay, before moving the service from blue deployment to a green deployment, what we are going to do, we are going to do some checks for our, or I would say UT checks and all in this environment. If it looks good, then we are going to redirect our traffic. I would say redirect our traffic from blue to green deployment. I would say this one does not work on the basis of replica set. It works on the basis of deployment. So in terms of costing also, it would be rolling update or the recreate. Why? Because here we have a single deployment, and this single deployment is managing multiple replica set. Well, in this case, what we have two deployments. The first deployment is blue deployment. It has its own replica set and pods, while in the case of green deployment, it has its own replica set and pod. But it has some benefit also. So before moving the workload from green to blue or from blue to green, we are good to do some testing and to check the configuration. The other options which we have is using Canary deployment, it will make sure our 100%, I would say, our 100% traffic will not go to the new deployment, means our green deployment point. We are good to control, I would say, only 20% of the traffic is going to go inside my green deployment. If it is up to the mark, then we'll make sure update all our traffic to 100% to the new deployment. So basically, blue and green deployment is the upgraded version of our rolling update. It will make sure 100% there would be no any kind of downtime. Before moving from version 1 to version 2, we are good to do some UAT testing or the other configuration checks, or we are good to control the amount, the percentage of traffic which we want to go to the new environment. If the feedback looks good, we are good to run the configuration. So let me quickly do this demo for it. Look in the Visual Studio Code. I will create a new YAML file named called as blue.yml. If you see in this YAML configuration, we have blue-deployment, the replicas is 5. Then we have the selector, the template, and the version is v1. And then the other object which we need to create is service for blue-green. If you see here, we have kind service. This is the name of my service. The type is LoadBalancer. This is the port. This is the target port, and the selector is blue version. Clear my screen. We'll run a command called kubectl create -f blue.yml, and then the next command which I'm going to run is kubectl create -f, and the file name is bgsbc. Okay, I'll run a command called kubectl get svc. So the external IP is pending. Let me mention -w, and so this is my external IP. We'll paste this configuration. Okay, so this is my version 1. So it is same thing whatever we have done till now. This is showing the welcome to blue deployment, and this is my port. So what we have implemented till now, we have created, I would say, one deployment, and then this deployment is connected to my service. Okay, let me create one more deployment name called as green.yml. And what we have in this YAML configuration, I have mentioned the replicas 5. The name is green-deployment, and this is my image version. Okay, let me run this configuration. I will run kubectl create -f green.yml. I will run a command called kubectl get deployments. So what we have 3 deployments, but we are good to ignore this one. This one is from my last example. So we have 2 deployments, blue deployment and the green deployment. In the blue deployment, we have the 5 pods, and in the green deployment, what we have the 5 pods. So it would be like this. We have our service, okay, and then in this service we have a blue deployment, and then we have the green deployment. Currently all the traffic is going to where? To my blue deployment. I would say right now I have created this green deployment and I have shared with my QA team, and they are checking some load testing and the other things, and they are saying like, okay, we are okay with this version. So what I'm going to do, I would say I'm going to redirect the traffic from the blue deployment to green deployment. Okay, and the green deployment again, I would say this is my version 1, this is my version 2, and if it looks good, great, then the next version v3 I'm going to update here, and I will again do some testing and all and check the configuration. If it looks okay, I'm good to redirect the traffic from green to, means from this version to this version. Okay, So to update the service, what I'm going to do, I will run a command called kubectl get service. We'll edit the command. We'll edit this service kubectl edit svc bg svc. And if you come here at the bottom, what it is showing? It is showing selector version as blue. I will update here as green. I'll save this file. I will close this one. Okay. And if I'm going to refresh this URL, see what we are getting? We are getting a green deployment. Okay. See, we're able to see all the pods which are related to the green deployment. If you see here, we are while moving the deployment services from blue services to green, we did not face any kind of downtime. Even if you compare with the rolling update strategy, the blue-green deployments are more faster because the blue-green is not going to create a new replica set. Instead of it, it uses what? It uses a deployment level thing. So in most of the production environment, you'll see the blue-green deployment, but the main issue of using a blue-green deployment is in terms of costing here, because we are managing two deployments. Well, in the case of deployment also, so to manage the blue-green deployment, I would say it is a bit complicated in comparison to the rolling update. The second option, which I would say in terms of costing also, because we are creating two deployments and we are managing it. But in real-time scenario for complicated application, what we use blue and green deployment. So we have completed our blue and green deployment discussion, but still we have one challenge. As I have mentioned, what we are doing, we are moving 100% of our traffic from blue to green. In real-time scenario, what we need to control this traffic to move from older version to the newer version. I would say 80% of the workload will go to the blue deployment, and then 20% of the workload will go to the green deployment. And later on, if everything goes well, we will decrease the traffic for the blue one and will increase this one. This type of service is basically called as Canary Deployment. Okay, so in Canary Deployment, we have a controlled how much traffic we want to redirect to this blue deployment or the green deployment. So let's do a quick demo to understand this one. I'll create a YAML file name called as Canary Deployment.y. So I'm going to create a file name called as canary-deployment-blue.yml. If you see here, what I have done in a single YAML file, I have mentioned the deployment and I have mentioned the service. So if you see here in deployment, the metadata is the namespace I have mentioned default, and the name I have mentioned Canary-blue. The replicas I have mentioned 3. Then we have the selector, and here I have mentioned the strategy. I have mentioned the strategy in terms of maximum surge 1, maximum unavailable 1, and here is my template. And finally, once my deployment has been created, I'm going to connect with the service, and then the service will give me a public IP. So this is my service configuration detail, and I have mentioned the type as load balancer. Let me run this YAML configuration. kubectl create -f Canary. I will run a command called kubectl get deployments. I will run kubectl. Okay, so Canary-blue, it has been created. The next command I'm going to run kubectl get svc. And the IP is this one. You see here, right now we are able to see all the blue pods. Okay, in terms of diagram, it would be straightforward. What we have done, we have created a new deployment, and then this deployment is connected to my service, and then this service has given me what? A IP, and using this IP we are able to see what? All the blue pods. Okay, the image is blue only. But as I have mentioned, in real-time scenarios, when we are moving from service, from I would say from blue deployment to green deployment, advisable, so it is not recommended to switch the 100% of the traffic. So what we do, we generally moving the traffic, I would say, in slots. In first slots, we release 20% of the traffic to green version, and 80% it would be blue, and everything looks good. Then we are going to move 40% of the traffic to green and 60% to blue. Okay, and once everything looks good, then slowly it would be 100% to green and 0% to blue deployment. Okay, so to control this kind of behavior, what we need to use? We need to use a canary deployment. Okay, so the next YAML file which I'm going to do is canary-deployment-red.yml, and here if you see what we have, the kind is deployment, the name is canary-red, the replicas is one, and selector is canary, and this is the template, and this is the image which is going to be used. Let me run a command called kubectl create -f canary-deployment-red.yml. Okay, it has been created. I'll run a command called kubectl get deployments, and see in our red deployment what we have mentioned one pod, and here what we have mentioned 3 pods. Okay, and both of them are connected, and let me refresh this. Initially what we had 100% of the blue pod. Okay, but later on we created one pod with red configuration. We are able to see red pod. So initially what we had 100% blue pods, 75% blue, and 25% as red. So this feature is generally called as canary deployment. How we are able to achieve? Let me show you in this YAML configuration. So if you see here, what we have done, we have created a deployment name called as canary-blue, and in this one what we have done, we have created replicas 3, means in this one 3 pods are going to be there, and then the match labels is canary, and then we have the template and the specification. In the specification it is blue color. In this canary-red, what we have done, we have one pod, and the pod image is using red, and in terms of selector it is same only. Then what we have done, we have created a service. Okay, and in the service, the selector name what we have mentioned, the canary, and the 3 of the services coming from here and 1 of the services are coming from here. If I'm going to update this one as 4 pods, and this one I would say as 1 pods, I would say 0 pods, and let me run this configuration again. CTL apply -f. Okay, I'll run again for my red configuration. Okay, I'll run a command called kubectl get deployments. There is one typo. Okay, if you see here what I have done, the canary, I have updated this replicas to 0 for this one. From 3 it is 0, and from 1 I have updated it to 4. Let me check in the URL. So in current scenario we are able to see 0% blue pods and 100% of the red pods. Okay, so this is one of the type of the blue-green deployment, which is called as Canary deployment, in which we are able to control the amount of traffic which is going to the blue deployments or the green deployments. In real-time scenario, we generally use this approach in which we are able to control the traffic. How much percentage do we need to flow to the blue deployment or to the green deployment? So with this, we have completed our deployment discussion. What we have covered: firstly, we discussed why we need deployments. Then the second point we discussed what are the various types of deployments. The first one we discussed is rolling update. Then we discussed about the recreate. Then we discussed about the blue green, and in blue green we discussed about the Canary deployment. In rolling update, we will make sure we are not going to have any kind of downtime. While in the recreate, we are going to have a downtime because it is going to delete the pods which are present in the old replica set. Then it will redirect the traffic to the new replica set, and all the pods are going to be created. The third type which we discussed is blue-green deployment. So till now what we have done in rolling update and recreate, we were using the replica set, but in blue-green deployment we are going to play at the service level, and then we have two environments, blue deployments and the green deployments, and we are good to redirect the traffic from blue to green deployment, and it provides more control over the deployment because before deploying the new version, we are able to do some UAT testing and the other configuration. But it has some drawbacks also in terms of costing. It would be double. In terms of management also, it would be double because we are here managing the two deployments. Then the last one which we have discussed is our Canary deployment, where we are not responsible to move 100% traffic from the blue deployment to the green deployment. In this case, we are able to control the traffic, I would say, in number of pods. Like in blue deployment, we have the 3 pods, and the green deployments, we have the 1 pod, which means 75% of traffic will go to this pod, to this deployment, and 25% of traffic will go to this deployment. So everything looks good in this deployment. We are good to move this one to 0 deployment and all the pods here. With this, we have completed our deployment discussion and the different types of it. So thanks a lot for watching the video.